Welcome to Point Primer Part 3. In this section we are going to use spatial analysis and raster a little bit to understand the point pattern better. What we've got to use at the moment is one of the few really big open data set that contains geo-reference material for Sweden that I am available, that I could share. In fact, I'll try to make a link on the web page on YouTube and see if you can download it. Let me know otherwise. I've named it Farm and Animals, and it contains information about the whereabouts of all Swedish farms that has got either cows, goats, sheep, fowls and pigs, and simply because animals on a farm might act as vectors for various kinds of diseases, so it's important to trace and know the number of not individuals, but farm animals and what kinds there are at specific locations. As you can see, it pretty much depicts the contour of populated Sweden. Up here in the northwestern parts, you've got very few individuals. In the southern, it's dense with both people and farm. So, if I zoom in on the Stockholm area, it's potentially quite a few. But if you compare it to the more farm-oriented areas here in Västergötland or somewhere in the southern parts, you got so many more farms simply because there's more agricultural activity over there. But it's difficult to spot any direct sort of patterns of the animals. If we do this, if we right-click on Farm and Animals, and we'll try to see. It takes a little time for us this time to see if we can find any of the. Let me see the pig. Let's see if we can find any depiction of the patterns. We could see that first of all it's a little bit too big. But if I zoom in on an area, we could see that you can detect areas that are more brown and others that are more blue. But it's very difficult to say something about the concentration. We need to do some contextual analysis where we look for the neighborhood surrounding each of these pig farms, or the farms in general, and try to understand, are there any sort of bigger pictures that we can't see. There's one way we could do is to use spatial analysis, the built-in toolbox in ArcMap, and from that we could look at the neighborhood counts. We specify a radius and we count the number of farms within the specific radius, and we do the same for the number of pig holding farms, and then we create a ratio. And this is what we will do in part 3. So we will use a raster technique to collect the information about, but thereafter we will do something called extract values by point, so that we make the points that we see right now be the collectors of the data after the raster calculators have been completed. In the fourth part of this sort of point primer, we are going to move into K nearest neighbor analysis, which is, rather than looking at the radius, which we are doing right now, looking for the count of neighbors to specify the neighborhood or contextual analysis. So, in order to do this, to get this running today, we'll look for the tool, and I've already tried it. It's located in Spatial Analysis, the neighborhood, and the point statistics. So if I double click this, I get these options. I can enter the farm and animal sort of shapefile, and I choose in this case the pig to be the field that I want to express. And the output raster could simply be called, I don't know, we could keep the default values. And I want the output cell size to be 100. And I choose a circle because I think a circle is much better representative of sort of a radius than a box is. And I'm going to choose 3,000 meters. So from one end to the other you will have 6 kilometers. That's quite a long distance, perhaps not enormously big, but at least it will give you a depiction of the neighborhood in which farm animals may exist. And what we will do is not have the mean, but rather have the sum of pigs within this area. So any farm holding pigs will be counted as 1. And I'll be able to say so because you could see the values are 0 and 1, so the ones not holding pigs have the value of 0. So summing it up actually counts only the ones having pigs. You click 1 and it thinks for a while. It might be something that takes a while, so I'll wait in the meantime. Now the computations are ready, and we can see that the pig counting values ranges from 0 to up to 19. So there are one location in Sweden where you got as many as 19 pig holding units within a diameter of 6 kilometers. That's quite a lot. If we hide the vector graphics, we could see that we could see something of the distribution. It says more. It seems to be denser concentration of values, higher values down here than in specific areas. But it only says something about the concentration of pigs. It doesn't say anything about the denominators and denominators. It doesn't say anything about the relationship. It might just be that we've got a high concentration of farms. So in order to understand what we're going to do is that we also need to redo this point statistics, but rather than having the pig being counted, we need to do it on the farm basis. In this case, every farm is being counted. And just to keep trace of things, I'm going to call this farm count, so we know that works. The other things I'll keep the same, 100 and 3000, and the sum of values. Now, after these computations, we could see that the highest value we've got is 72. So we've got in one location sort of a full 72 farms within that kind of 3 kilometer radius, which is quite a few. And out of these, in one location, we also got 19 pig locations. So we don't know the relationship. This is for us to find out. The first thing we need to do is to find the function extract values by point. So what I will do is I'll go to the search function, which is there. And I have already searched for the value extract, and I can see that I got extract values to point over here. And if I click for that one, we enter the point features, which are, as the original ones, the farm and animals, and the input raster would be the farm count in the first place. So I'll call let's call it farm points in this case, which means that the values from the raster is being given to the original point file. So if I click this one, it will think for a little while. So for every single point, we will look for the values underneath in the raster. It will do a spatial join, and it will return the underlying raster value to the point value. And there it's ready. So for all these points, they are now specifically the same locations as the original farms, but they are enriched. So at any location here, we could see that these values also have the embedded value of the raster within. And we can look for it by using Open Attribute Table. We can see in the end that we have something of a raster value. We know in this case that the raster value then represents the number of farms within that diameter we specified. We need to do something, and that's changing the name of these of the raster. We actually need to add an additional field, and I'm going to call it farm count within as a value like this. The reason is that the next time we're going to do extract values by point, it will actually collide and say it can't do it because the value of raster value is already occupied. Since we want to do it 2 times to have a denominator and denominator, we want to change it. So what I'm going to do here, I've created an empty numeric variable called farm count, and I go for the field calculator, and I simply specify that the farm count should have the value of the raster value. It's simple. Just double click these ones and click OK, and it will go through the complete sort of vector of raster values and fill it and spill it over to the farm count. Thereafter, we can right click on the raster value and delete that field. Having that down, we now have the opportunity to go and return, and instead next time when we do this extract values by point, we don't use the original farm and animals, we use the farm points that holds the value of the number of farms. And the input raster this time would be this 1 point shape 6, which unfortunately wasn't changed when it came to the name, but holds the number of pig holding farms. And I can rename this farm point plus pigs this time, to make sure we got all the values and names. And it's the same procedure as last time. From each of the points it will look for the values underneath in the raster, but this time from the raster called point st shape 6, which hold the number of pigs. So both values, the total amount of farms and the total number of pigs, will be present in the new shapefile that hopefully will sort of surface any second now. There we go. After quite a long time, the final point file called farm point plus pigs have collected all the information. And if we look for the open attribute table, we will be able to see that we've got the raster value, which then holds the number of pigs, and the farm count being a value of 34. Simply because we've got so few variables, we can keep the value of raster value. We know it's the number of pigs, it's nothing else. Otherwise, I would highly sort of advocate that people change the names, but using sort of add a new field or rename the old one to make sure that we remember what we're actually doing. In this case, I'll right click and I go for the properties. It will take a little while because there are so many points, and it takes a time to actually read in the attribute table and all these things needed. And I'll go for the symbology, and I'll go for the quantities, and I'll choose the raster value, which is the number of pigs, and I will divide it by the number of farms. And it must be a value between 0 and 1, because the number of pig folding farms can't be bigger than the number of farms. And as we could see, it ranges between 0 and 1. If I go for tens, we got something of a span of values, and I click OK. We will see that we have some kind of a pattern. Let me see if I can close. Let me see if we've got something of a beautiful pattern here. It's actually quite interesting, I'd say. So the bluer the color, the greater the concentration of pigs. And we can see it's more pigs in these areas and closer to the waterfront. And, well, seems to be an interesting pattern of it. This is on the national level. I'm afraid at this level the points are too big. I should minimize them, but I really don't see that as the part of the lecture today, so I'm just going to zoom in and see what happens in the Stockholm area. Well, not that many pigs. Could be that pig farming actually smells quite a lot, and it's not popular in densely populated areas, so the major color is brown, consistent with no pigs and very few pigs in the farming area. So that's one way of dealing with this. Of course, this material could then be used in statistics and do regressions and whatever you want. But it's an easy way of doing a contextualization with the points, where you collect, where you transform the original point values to a raster, you do a quota, and you recollect the material into the points, so you have an idea about the composition surrounding you. The problem with these kinds of radii-based statistics is that 3 kilometer radius doesn't really say much. If you're living in a very densely populated, pig-populated area, if you like, you've got a long variety of different farms that can contribute to the variability. But if you live in a very remote area, let me see if we can find any remote areas, predominantly, I guess, in the upper north, you could see that the radius is actually just encircling 1. So either you've got pigs, which you seem to have in these areas. I'm going to point there. Or no pigs, where it's brown. So these kinds of techniques don't really work well if you're counting ones and ones and ones. If you do want to have a count that is more representative for the number of units, you're going to go for a k-nearest neighbor analysis. On the other hand, if you're counting things that has got to do with epidemiology, on say that the spread of a disease goes through the air, then the distance between farms is of high interest, not the number of nearest farms. So if there is anything that is purely related to distance, doing a radii-based contextual analysis, as we just did, is the absolute best choice for us to do. If we think it's got something to do with the neighbours and the farms, it could be a marketing thing, it could be a vet that want to set up a business. It's not the number of farms within the 3 kilometers, it's the density of some kind of a farm or some kind of need within the nearest neighbours that actually is of an interest. So we end here with this part for the radii-based contextual analysis. And in the fourth part, we'll go for the k-nearest neighbor analysis.